The chain rule, of course, can be used multiple times in the same problem. Let's see how it works. So suppose instead of just having f of u of x, we had f of u of v of x. Something like that. So we have 1, 2, 3, just like that. Well, how would you compute df dx? Well, as it turns out, it's just df du times du dv times dv dx. So notice that everything links together like a chain. The du's cancel, the dv's cancel, and we're left with just df dx. Expressing it the alternate way, it would be f prime of u of v of x times u prime of v of x, and then times v prime of x. It makes sense. We're just following the pattern, right? So it's the derivative of the outermost function with respect to the whatever, this inside stuff, and then times the derivative of the next outermost function, so the derivative of u with respect to its argument, and then times the derivative of v with respect to its argument, and so forth. We can even go further, f of u of v of w of x. Why would anyone want to do that? Why not? Let's do it. dy dx would just be f prime of u of v of w of x times u prime of v of w of x times u v w prime of x, I skipped the v, right? Times, so it's u prime, and then times v prime of w of x, and then times w prime of x. So it just it forms a chain. So it's basically df du times du dv times dv dw times dw dx. Link it together, the w's cancel, the dv's cancel, the u's cancel, and we just have df dx. The formalism might be even more complicated than actually just doing it in practice, because doing it in practice, you're just applying that same basic rule that you learned before we learned the formalism of the chain rule in the first place. Remember, I incorporated the chain rule automatically into the 5 basic derivatives rules in order to generate the 5 basic derivatives plus. So you can already get the feel for how the rule works without necessarily, even understanding all of the formalism. So let's see how the rule works in practice, and we won't even worry about the f of u of v of w of whatever. We'll just do it. So once you get the intuition for how it works, you get the feel for it, you can just do it without worrying about what u of x is and v of x is. Unless, of course, your instructor wants you to identify those sorts of functions. But in practice, when you're solving real problems in engineering or physics, you have a complicated function, you just sit down and you go through and you write it out without necessarily identifying what each rung of the chain is. So let's say we have y is equal to, or let's call it f of x this time. Let's say f of x is equal to e to the sine of the square root of 3x squared plus 4x plus 17. Just like that. E to the sine of the square root of 3x squared plus 4x plus 17. A couple chain rules going on. So you might imagine a function like this. So it's not that far-fetched that we would want to link together the chain rule a few times. F prime of x, so let's see how it works. It's just e, you put a blob around everything you can. It's e to the blob. So we take d by d blob of e to the blob. And we just get e to the blob, right? E to the blob. E to the sine of the square root of 3x squared plus 4x plus 17. So that's just d by d blob of e to the blob. See, it's just e to the blob. And now we just multiply by the derivative of blob. So the derivative of, now we have to figure out what the derivative of the exponent is. So whatever this is, it's going to be the derivative of the red stuff. Now what's in the red stuff? Well, it's sine of something. So it's sine of a new blob. Right? So it's sine of something. So we just have to take the derivative of sine of something. Well, what's the derivative of sine of something? It's just going to be cosine of something, right? Derivative of sine is cosine of something, so it's just going to be the cosine of this something, 3x squared plus 4x plus 17. Right? So the derivative of sine of something is cosine of something. So here we had sine of something, its derivative is cosine of something, and now we have to multiply by the derivative of that something. So we have to then multiply by the derivative of this guy. Now this happens to be something, or new blob, let's call this one chunk. It's just chunk, square root of chunk. It's chunk to the 1/2. Well, what's the derivative of chunk to the 1/2? It's going to be 1/2 chunk to the minus 1/2, so it's going to be 1 over square root of 3x squared plus 4x plus 17. So it's 1 over square root of chunk, 1 over 2 square root of chunk. Right? Remember, x to the 1/2, the derivative is 1/2 x to the minus 1/2. So here's the 1/2, and here's the chunk to the minus 1/2. And of course, that inside function, I guess I should have done this one in green to stay consistent. Oh well. So then next we have to multiply by the derivative of the chunk. So the chunk this time was 3x squared plus 4x plus 17. So then we multiply by the derivative of that, which is 6x plus 4. See how everything just lined up like that. So we had e to the sine of the square root of 3x squared plus 4x plus 17. So it's e to the something, derivative of e to the something is e to the something. Then we multiply by the derivative of that something. Okay, so let's look at what this something is to figure out its derivative. It's e to the something times the derivative of something. That something was sine of chunk. So the derivative of sine of chunk is just cosine of chunk. Great, now let's look at chunk and take its derivative. Well, chunk was the square root of something. So the derivative of the square root of something is 1 over 2 root something. So we get 1 over 2 root something, and then times the derivative of that something, which was 6x plus 4. And that's how you work it out and how you would link the chain rule multiple times. Let's do another example. Why not? Sine of what? Sine of, I guess it could be anything, e to the 4x cubed plus 8. It's slightly less complicated, not bad. Okay, so how do we take the derivative of this? Well, let's start off by writing f prime of x. And we have sine of something. So the derivative of sine of something is just cosine of that something. Right? So basically you're just viewing that inside complexity as just a solid piece. Sine of chunk, derivative of sine of chunk with respect to chunk is cosine of chunk. And then you multiply by the derivative of the inside. So we multiply this one by the derivative of this. Okay, now to take the derivative of this, we have e to something. So we have e to this bubble. So the derivative of that is just e to the bubble. Exactly. And so we have just e to the bubble. And then we multiply by the derivative of the bubble. So we get 12x. And that's it. Derivative of sine of e to the 4x cubed plus 8 is just cosine of e to the 4x cubed plus 8 times e to the 4x cubed plus 8 times 12x. So you see how these get linked together piece by piece. And those are two examples of how you would link the chain rule together multiple times to find the derivative of a more complicated function.